Hi, and welcome to this lesson on searching for solutions, driving throughput beyond uncertainty. When it comes to projects and innovation, we always have to start with understanding the buyer system. Now, this system isn't necessarily just an organization. It could be a restaurant serving meals, it could be a consumer commuting to work, it could be an organization that serves clients or a government agency that regulates markets. It also could be a manufacturing plant filling orders. In all cases, it is the buyer system which we must start with and understand completely in order to align the objectives. And when we understand systems, we should be looking for the constraint. Almost all systems are limited by just one constraint. When we talk about looking for the constraint, what we're actually talking about is looking for the bottleneck. Now, the bottleneck is going to be that point in your process, in your system, where the throughput is most constrained. The indication that it's constrained is that usually that bottleneck is running at full capacity, and it usually also has a large backlog of work. If we look here at this first example of a system where we have processes A, B, C, D, and E, we can clearly see the bottleneck C because of the fact that a lot of work is backed up before C, and the processes after C don't have very much work in them at all. If we understand that the organization is going to measure its profit as throughput minus the operating cost, we can simplify this to just the number of units sold minus the work in progress, or those dots that you see before each one of processes. In the baseline scenario here, what I've offered is that we have a throughput of 80 sold, and at the same time, we'll have an operating cost of 60 items that are work in progress. So we have a profit of 20. Now, what if, in order to serve the bottleneck better, we were to reduce the operating efficiency of A so that it only operates 15% of the time? If we did this, based on the math that you see here, where A produces 14 times more work than B can handle and 28 times more work than C can handle, then we can actually reduce the amount of work in progress and still not affect the throughput at all because the bottleneck is still at C. This is something that we need to internalize and understand, is the fact that throughput is always limited by the bottleneck. Just by reducing the effectiveness of A, we've actually lowered the total cost down from 60 items that are work in process to only 10 items that are work in progress. And then finally, what if instead of reducing A, we decided to increase the speed of C, effectively elevating our constraint, our bottleneck, so it worked twice as fast? Well, then we would actually be able to sell more units. We'd double the total throughput, and we'd only be limited by the new bottleneck, which is B. So if we do the math based upon the numbers provided here, our throughput would be 160. The operating cost would be 22 items that are work in progress, and the profit would be 138. This is oftentimes what we find in systems, no matter how complex or different, be them a restaurant, be them an organization that's regulating the industry. Increasing speed and throughput is almost always going to deliver better results. That's why speed wins. And if you want to understand this even better, I highly recommend that you take the Driving Speed course if you haven't already, Driving Speed through Agile Planning. Now let's talk about cost accounting versus throughput accounting. Cost accounting is the old world costing method. It focuses on local performance based upon the potential of every unit within a process to perform and to be efficient. Costs are calculated locally, and oftentimes we look at a performance based upon a ratio, throughput over cost, for each item. Throughput accounting says that that system is flawed, and instead we need to manage the whole system and maximize throughput while also limiting costs for the system, like we saw on the previous slide. Costs are measured globally, throughput is measured globally, and what we do is we improve by focusing on the parts of the system that are constraining throughput. Because if we can unleash throughput, we'll oftentimes lower costs and we'll definitely make more money through revenue. So when we compare this in a simple scenario, I've brought back the example from before. And what you can see here is that in the cost world, managing efficiency at 100% for all the systems results in a lot of work in progress. This is what we see in the top line. A is running at 100% and creates a huge backlog for B, which is running at 100%, which creates a lot of backlog for C, which is our bottleneck. And then afterwards, processes D and E are running as fast as they can whenever they can. The result, a thin margin. But simply by recognizing that local performance doesn't mean system-wide performance, if we lower the local efficiency of A, we can actually decrease the cost in the system and achieve much greater throughput. If we do so for B, we can even lower our costs even more. And the result is a much higher profit rating. So understanding the difference between the cost world and the throughput world is understanding that we need to manage systems as systems. Hi, I hope you're enjoying this free lesson from the University of Maryland's Project Management Center for Excellence. If you want to check out more lessons just like this one, click the link in the description below where you'll be able to go to our website on executive project management. There, you can find edX courses, professional short courses where you can learn from an instructor like me, as well as request custom team training for you and your organization. All right, let's get back to the lesson and I'll see you at the end. So again, projects must impact the system in order to make an impact to the buyer and derive benefits. Projects that don't improve the whole system just drain resources. They just add to cost because there's been investment and delay of capital. The problem is always that systems, though, are too complex to understand. In order to understand what's going on in a system, we have to test solutions because modeling a system is much more complex than just 5 processes A to E. The way that we do this in Agile is that we develop iteratively and incrementally. We take small chunks of work, the most important, the highest impact work, and then we deliver them and we test in the buyer systems to see if we're making a real impact. If we are, then we continue in that vein and we continue to work around the constraint, lowering costs that are added by not matching the constraint and elevating that constraint or that bottleneck so that the system has greater throughput. The reasons that we oftentimes give for not being able to do this is that there are competing objectives in the organization, there's changing requirements, there's an inability to read minds, many different arguments exist. In the end, we normally call this risk management. So because of this, if we think about it, innovation management is actually risk management. And then what is risk? Risk is uncertainty quantified. All projects have uncertainty, and it's those risks that are the highest and the ones that we can quantify that we manage. But in reality, we have to manage both the uncertainties that we can quantify and put numbers and probabilities around, as well as those uncertainties that we can't quantify. The general buckets for uncertainty are business uncertainty, technical uncertainty, and environmental uncertainty. There are many different types of uncertainties here, and you can see them. But uncertainty isn't always a bad thing. In fact, innovation lives in uncertainty. If we were certain about everything, there'd be no need to innovate. And uncertainty gives us an opportunity to advance and to go faster, like we talked about in driving speed. But among all these uncertainties, the greatest risk to a project is that the user doesn't need and does not adopt your solution. That is always the greatest uncertainty which we must be constantly managing. So in summary, we need to derive value by aligning the impacts of our project to the buyer system. And we have to make sure that we're using a throughput accounting method to understand if we're actually improving the buyer system with greater revenues or with lower costs. The biggest impacts are always going to come from unleashing throughput. Agile does this by testing solutions. We put solutions into the buyer system to see if they're working. Oftentimes the systems are too complex to fully model, so we go with a test-driven approach. But of course, this gives us an opportunity to learn as well. And we'll get feedback from putting those solutions into the environment and then seeing how they come back. Finally, innovation management is risk management. And in fact, it goes beyond just risk, but general uncertainty. And we need to find ways of taking advantage of that uncertainty and being able to come up with solutions despite it. Always focusing on the user, because user adoption is our greatest uncertainty and the greatest risk to projects in general. So I hope that this has been useful for you and that now you have a better understanding of why we search for solutions in Agile and we are always driving throughput beyond uncertainty. We look forward to seeing you in the rest of the course. Hey there, did you enjoy that lesson as much as I did? If you did, go ahead and give us a like. If you want to see another one, go ahead and subscribe. And if you have any questions or comments, put them below and we'll get back to you as soon as we can. Moreover, is there somebody in your life who really needs this lesson right now? If so, go ahead and share it with them. I'm sure they'll appreciate it. Now, we look forward to seeing you in the next lesson where you can learn even more from the University of Maryland Project Management Center for Excellence. Thanks so much.